Myself and Arun Kumar from SS College of Technology in the Department of ECE. In this video, we are going to see about modeling of electrical systems. The modeling of electrical systems in control systems are the elements which are useful to training the models based on your input and output sequence. So let us see how the basic elements and their inputs has been involved in control systems. So there are two types. One is static systems, another one is dynamic systems. In static system, if a system does not change with the time, it is called static. And if it is dynamic, the system change with time, it is called dynamic systems. This has to be followed in the upcoming slides. Dynamic systems. A system is said to be a dynamic if the current output may depend on the past history as well as the present value of the input variables. So mathematically, y of t equal to q of u of tau 0 tau less than equal to 1, because it is based on your input and time. So if your time and input is based on the equation, then automatically the block will be moved towards the other blocks. For example, a moving mass m is having an input u and the transition function as y. So the model is force equal to mass into acceleration, mass into acceleration y. Way to study a system. A system is functionality of the control system, which is divide the input system as a lot of conditions based on the simulations. For example, the system has to be followed the physical and mathematical model. After getting the simulation of the results, it has to be divided by frequency domain, time domain, and hybrid domain. Model. A model is a simplified representation or abstraction of reality. Reality is generally too complex to model exactly. So model used for simulation process, prediction, diagnostics process, design or performance evaluation, control system design. Basic elements of electrical systems. So based on the input signals such as resistor, capacitor or inductors, these are all some basic elements of the control systems. It can be written as constant voltage or current equations. For example, if for based on the Ohm's law, it can be written as V of t equal to I into R, V equal to I into R, so that the Laplace transform of the concerned equation can be calculated by I R of S into R. So like that, all the elements has to be followed. 1 by C capacitor and 1 by Cs of IC of SEC is the form of Laplace transformation. And inductance also, L is an inductance, di of differential equation of L with respect to time. It can be calculated as in the form of Laplace transform by L into S IL of S. So the voltage and current relationship between the resistor and capacitor inductance can be followed by V equal to IR. So the same equation for IV, it can be reversed because so it can calculate I equal to V by R. So like that, all the equation has been rearranged and calculated based on the inductance or resistor or capacitor value. Example 1. So here they are connecting a two-port network shown in the following figure. Based on the input and output voltage, we can calculate the transfer function of the networks. So already we have studied that transfer function is output by input, V naught of t divided by V of t. We have to calculate output voltage with respect to input voltage, so that we can calculate the transfer functions. Already we know that how to divide this problem means two loops we have to divide. So your first loop is Vi of t and second loop is V naught of t, because we have to calculate the transfer function V naught of t divided by V of t. So initially the Vi of t can be calculated by based on the elements present in the example. Here the values are resistor and capacitors are connected in series, so that we can write the equation as Vi of t equal to I into I of t into R plus, already we know the capacitance formula is 1 by C into integration of I of t into dt. So like that, the output voltage of second loop can be calculated by, so here only one medium is connected, capacitor alone connected to the output of the voltage. in this loop, so that the equation becomes 1 by c integration of I of t into dt. So after calculating all the equation, we have to convert as a Laplace transform, so that we can get the final equation via V naught of s V of I is equal to 1 by 1 plus RCS, because after cancelling all the steps, we can rearrange the steps so that we can calculate the final equation as output by input is 1 by 1 plus RC of s. So design an electrical system that would place a pole at 3 if added to the other system. So the same equations, the same formula, the same problem we have discussed earlier. So only thing is, we place a pole, the pole in the medium of the corresponding equivalent circuit, so that how the system has been reversed. So in this output voltage can be already output by input voltage already calculated as 1 by 1 plus RCFS. The only changes system has one pole. So we can include the pole equation as S equal to 1 by RC. Therefore the equation becomes, because we are adding pole at minus 3 in the middle of the equivalent circuit, so that the equation has been changed as minus 1 by RC equal to minus 3. So after inserting this value as to the transfer function, we can get the final answers. So the random value of the resistor and the capacitor value, the default value has been put it as R equal to 1 megaohm and C equal to 333 parafarad, so that we can get the corresponding transfer function as a correct one. Thank you.